So, we can get x minus 1 we can cancel. So, instead of finding expected value of x square directly, we will find expected values of x into x minus 1 first. Then what will be the benefit? So, if you find expected values of x into x minus 1, so this is nothing but expected values of x square minus x, which is nothing but expected values of x square minus expected values of x. So, then you can simplify like expected values of x square, this is the mu 2 dash, this is nothing but expected values of x square, it is nothing but expected values of x into x minus 1 plus expected values of x. Expected values of x we have already computed here, this is lambda. Now, expected values of x and x minus 1, so this is we will compute, then we can find this value. So, let us first compute expected values of x into x minus 1. So, expected values of x into x minus 1. So, let us find out this value first. So, then this is nothing but summation of by definition x is equal to 0 to infinity x into x minus 1 pxx. Now, this is nothing but see that. So, this is nothing but summation x is equal to 0 to infinity x into x minus 1 e to the power of minus lambda, lambda to the power x by x factorial. So, now this is x is equal to 0, this is 0. So, this is nothing but x is equal to 0, this is 0 because x 0, even if x is equal to 1 also this is 0. So, then we can write x is equal to 2 to infinity x into x minus 1 e to the power of minus lambda, lambda to the power x by x factorial we will write x into x minus 1 into x minus 2 factorial. So, then these are cancelled. So, then we can get some convenience here. So, now e to the power of lambda, it is independent of the sum here, and also lambda we can write lambda square into x minus 2. So, that is why the lambda square will take common, this is x is equal to 2 to infinity lambda to the power x minus 2. See that this lambda square inside if you make, then it is lambda to the power x, that is matching here, and this is x minus 2 whole square. Then we will take the similar kind of transformation, take r is equal to x minus 2. So, then this sum will be 0 to infinity because the minimum limit of x is 2 and maximum is infinity. So, x goes to infinity, r goes to infinity, x is equal to 2, then r is equal to 0. So, this is nothing but lambda square e to the power of minus lambda, r is equal to 0 to infinity lambda to the power r by r factorial. So, then this sum again you know that this is lambda square e to the power of minus lambda, this is nothing but 1 plus lambda square by 2 factorial plus lambda cube by 3 factorial. So, this series it is known to us, this series already we discussed, this series is same as this again. So, this is nothing but e to the power of lambda. So, that is why this is nothing but lambda square e to the power of minus lambda e to the power of lambda. So, then this is nothing but is equal to lambda square. So, this value expected values of x into x minus 1, what finally we got, this is nothing but equal to lambda square. So, then this value how we will find, because this is lambda square, we will write is lambda square, and expected values of x already we found, this expected value by x is, this is nothing but lambda. So, this is nothing but lambda. So, this is nothing but lambda into lambda plus 1. So, mu 2 plus we found lambda square plus lambda. Now, we will find the variance from here. So, variance sigma square x, this is variance of x, this is nothing but expected values of x minus mu 1 dash whole square, this is nothing but mu 2 dash minus mu 1 dash whole square. Now, mu 2 dash we found, this is lambda square plus lambda minus mu 1 dash is nothing but expected values of x, that we already computed lambda. So, this is lambda square. So, then this cancelled, this is lambda. So, here you can see that this variance of a Poisson distribution is lambda. Also, we found that mean of the Poisson distribution is lambda. So, mean and variance of this Poisson distribution are same. So, that is the parameter lambda value. So, this is an example of a random variable that the mean and variance are equal. So, those random phenomena, the data actually having this kind of properties, like it is a discrete random variable, it is taking infinite number of values, countably infinite, but this mean and variance are equal, or then we can model it using the Poisson distributions. So, then now we will discuss some numerical example of the Poisson distribution, how we can utilize this Poisson distribution. So, we can find some application also, we will discuss some application of the Poisson distribution. Now, we will discuss some applications of the Poisson distribution. In the real life, there are many applications of the Poisson distribution. For example, the number of aircraft or road accident in any time interval. Usually in insurance companies, they need this information, what is the probability of the number of accidents, because they provide some insurance to the people, and they need to estimate that how many accidents may happen, and based on that they compute the premium they should ask to give from the people, so that they can use this for their profit, because usual people, common people, they may not know that what is the probability of accident. They can be scared about that this accident may happen, then there will be huge loss, but insurance company exactly can found the, or they can estimate the accident, number of accident that may happen. From that they can compute that what will be the exactly loss, so that they can profit using this technique. The number of arrivals in any service facility, like at an ATM, bank, railway station, petrol pump. So, whenever it is some kind of number of accident, number of service facility like ATM. So, this kind of data actually it can be modeled using Poisson distribution, and then bank can know that where this ATM can be established, or it can be giving the facility, how many ATM it will require, or petrol pump, the number of patients in a doctor clinic, the number of visitor to a mail exhibition, the number of service completed per unit time at a bank or any other service facilities. So, these are, whenever you will see in the real life, this is like some number of accident or number of service facility in a discrete sense. So, then you can use these Poisson distributions. Now, we will discuss some of the numerical example of the Poisson distribution, some of the numerical example. So, let us do some numerical example using the Poisson distribution, how can we can solve. So, a car hire firm has 2 cars. So, let us do one problem here. A car hire firm has 2 cars, which it fires out day by day, which it fires out day by day. The number of demands for a car on each day is distributed as Poisson variate with mean 1.5. Calculate the proportion of days, calculate the proportion of days on which 1, neither car is used, and some demand is refused. some demand is refused. So, you can see this problem. A car hire firm has 2 cars which it fires out day by day. The number of demands for a car on each day is distributed as Poisson distribution. So, let x be the random variable, let x be the random variable defined as the number of demands for a car on each day. So, it is given that x has Poisson, we write like this, it is a notation, x has a Poisson distribution with parameter. So, it is called mean lambda. So, expected values of x is, we know that whenever x is a Poisson random variable, so expected values of x is equal to lambda. So, now this lambda mean is, it is nothing but given 1.5. So, that is why this is nothing but Poisson 1.5. Calculate the proportion of days on it. So, they now here what will be the probability mass function? The probability mass function of x is given by Px of x, this is probability that x is equal to x e to the power of minus lambda, lambda to the power x by x factorial, whenever x is 0, 1, 2 like this, 0 otherwise. So, this is general probability mass function we discussed. Here it is given that lambda is equal to 1.5. So, that is why it is known to us. Now, calculate the proportion of days on which neither car is used. So, that means you have to find the probability that there is no demand. So, that is the probability that this x will be 0. So, that is this first probability we have to compute, nothing but probability that x is equal to 0. So, then you can have this lambda equal to 1.5, we will use e to the power of minus lambda. This probability is nothing but lambda is x. So, x is 0 here. So, that is e to the power of minus lambda, lambda is 1.5, e to the power of 1.5. So, this is the probability that proportion of days, that means probability that neither of the car used. And the next is that, next question is that also you find the probability that some demand is refused. So, when will the demand will be refused? So, demand will be refused when, because there are 2 cars only. So, demand will be refused if the demand is greater than 2. So, up to 2, then there will be some car, but the demand is refused means we have to find the probability that x is greater than 2. So, x is greater than 2 will be nothing but summation of x is equal to greater equal to 3, basically x is greater than 2 means x is greater than equal to 3. So, now instead of finding, because you have to take the infinite sum from 3 to infinity, that can be also done, but it is easy to find a complement of that. So, 1 minus probability that x greater than 2, that means it is x less than equal to 2. So, this is equal to 1 minus probability of x less than equal to 2, this is nothing but 1 minus summation of x equal to 0 to 2 Px of x. So, this is nothing but 1 minus summation of x is equal to 0 to 2, Px of x is nothing but e to the power of minus lambda is 1.5, 1.5 whole to the power x by x factorial. So, then this is nothing but 1 minus x is equal to 0, it is minus 1.5 plus it is x is equal to 1, this is e to the power of minus 1.5 into 1.5 plus x is equal to 2. So, x is equal to 0, x is equal to 1 and x is equal to 2, e to the power of minus 1.5 into x is equal to 2 is 1.5 whole square by 2 factorial. So, then you have to just use the calculator to compute it, e to the power of minus 1.5 into 1 plus 1.5 plus 1.5 square by 2 factorial, that you have to compute numerically. So, here I am just giving the answer. So, you can find, you can compute yourself, and then you can see that whether this is close to this value. This is nothing but 0.19126, 0.19126. So, this is one numerical problem we discussed. Let us discuss some more example, then you will be, it will be very comfortable to you will get very convenient to use this Poisson distribution. So, let us see some more examples here. So, suppose a x is a Poisson random variable with this given information. If x is a Poisson variate, if is a Poisson variate, x is a Poisson variate such that probability that x is equal to 2, this is nothing but is equal to 9 into probability of x is equal to 4 plus 90 into probability that x is equal to 6. Find the lambda, lambda is the Poisson parameter. So, basically find lambda, which is nothing but the mean of this random variable. So, how we can find this value? So, we have to see that we have let suppose if x is, so if x is Poisson random variable with parameter lambda, because lambda is the mean of this Poisson variate, if x is Poisson lambda, Poisson distribution with parameter lambda, we know that Pxx is nothing but e to the power of minus lambda, lambda to the power x by x factorial. We have to write the range x is equal to 0, 1, 2 like this. This is equal to 0 otherwise. Now, this is given to us. So, we can find out what is probability of x is equal to 2. So, probability of x is equal to 2. So, this equation actually we just directly put the x is equal to 2 e to the power of minus lambda lambda square by 2 factorial is nothing but 2, which is equal to 9 into e to the power of x to the power 4, x is probability of x equal to 4. So, we will put, so this is nothing but probability that x is equal to small x. So, this is x equal to 4 if you write e to the power of minus lambda lambda to the power 4 by 4 factorial. So, then plus 90 into probability that x is equal to 6. So, this is nothing but e to the power of minus lambda lambda to the power 6 by lambda to the power 6 by 6 factorial. So, then those values we have to know. So, now one thing that this is positive, lambda is a positive value, lambda is always 0 to infinity. So, we can just cancel those things. So, then we can see that e to the power of lambda and lambda square, we can multiply these things 2 by e to the power lambda by lambda square, then we will get 1 is equal to 9, just what I am doing, multiplying 2 by e to the power of minus lambda lambda square, because it is a positive number, you multiply both sides. So, then 9 into it is gone, now this is lambda square, and the by 4 factorial is nothing but 4 into 3 into 2, this is cancelled here, okay, I just write it. So, this is nothing but 2, because 2 by I multiply to the power e to the power minus lambda square, plus 90 into e to the power minus lambda, it is again cancelled with this, then lambda to the power 6 it will come lambda to the power 4 by 6, it will be into 2, 2 multiplied by 2, and 6 it is nothing but 6 into 5 into 4 into 3 into 2 into 1. So, then this 2 cancelled. So, just I am simplifying, this is cancelled. Now, 3 cancelled. So, then what we will get? So, here 2 cancelled. Now, here we can cancel more. So, this is 3 30. Now, 6 5, then this 5 also we can cancel. So, then you can see that most of the things cancelled actually. So, then just 4 is there. So, then we get this equation, I am just writing this equation, suppose we multiplied by 4 both side, then this is nothing but lambda to the power 4, we get lambda to the power 4 lambda to the power 4, we multiply it by 4 both side, lambda to the power 4 plus 3 lambda square, this is equal to what we are getting, this is equal to 4, we multiplied both side 4, this is 4. So, which implies lambda to the power 4 plus 3 lambda square minus 4 is equal to 0. Suppose if you, because lambda is a positive number, so let us denote another number, suppose alpha is equal to suppose lambda square. So, this is a positive number. So, then this equation will convert as a quadratic equation only, because it is a fourth this is power is 4. I want to, because we will feel better, we have some method we know. So, this alpha, if we write lambda square, then it will be alpha square, plus 3 alpha minus 4 is equal to 0. From here you can get this roots of this equation will be this is minus b plus minus root over. So, what we got this solution minus b plus minus root over of b square is 9 minus 4 into ac plus 4 minus 4 16. So, 4 into 4 a is 1, c is minus 4, 16 by 2 into 2. So, this is nothing but minus 3 plus minus, this is 9 plus 16 25, this is 5 by 2. So, because it is positive, so there are two roots, minus 3 minus 5, it is nothing but minus 8 by 2, this is minus 4, my negative number cannot be possible, as alpha is greater than 0, alpha is nothing but 5, only positive number, 5 plus 5 we will consider, 5 minus 3 by 2, so 2 by 2, this is equal to 1, which implies lambda square is equal to 1, again lambda also positive. So, since lambda is equal to 1, since lambda also positive. So, from here we can solve the values of lambda. So, this is another problem, like it is just another problem only. So, this is how to find the lambda. So, let us consider suppose let us consider some other problem also. So, suppose if x and y are independent Poisson variates, let if x and y are independent Poisson variate such that probability that x is equal to 1, this is equal to probability x is equal to 2. It is given, they are independent Poisson variate, probability of x equal to, and also it is given that probability that y is equal to 2 is nothing but y equal to 3. So, they are independent Poisson variate, but parameters are not known. Lambda 1 and lambda 2 are two parameters. So, these parameters are not known. So, then find the variance. It is told that find the variance of x minus 2y. So, then here we have to find the variance of x minus 2y. So, for finding the variance, because they are independent, this variance of x minus 2y will be variance of x. So, okay, so that will we have to know this formula. So, later we will discuss it. Whenever we will discuss the bivariate random variable, so then it will be, there is some kind of covariance concept. Here we will use this, later we will use this formula, but later we will discuss more details about this formula. So, first of all, let us find. So, let x has Poisson random variable with parameter lambda 1, and y has also Poisson distribution with parameter lambda 2. So, now it is given that probability of x equal to 1 is equal to, so what will be the probability mass function? Probability that x is equal to small x is nothing but pxx, this is e to the power of minus lambda 1 lambda 1 to the power x by x factorial, whenever x is 0, 1, 2. So, whenever 0 otherwise. Now, probability of y is equal to y, this is nothing but pyy, this is e to the power of minus lambda 2 to the power y by y factorial, whenever y is 0, 1, 2, this is equal to 0, otherwise. So, these are the probability mass function for x and y. Now, it is given that probability that x is equal to 1 is nothing but probability that x equal to 1 is equal to probability of x equal to 2. This is nothing but probability that x is equal to 2. So, now from probability mass function we know that x is equal to 1 if you put e to the power of minus lambda 1 lambda to the power 1 by 1 factorial. This is equal to nothing but probability x equal to 2. So, this is e to the power of minus lambda 1 lambda 1 2 by 2 factorial. Now, we have to solve this equation. So, this is cancelled where this is 2. So, 1 is equal to lambda 1 square by 2, which implies lambda 1 square is equal to 2, which implies lambda 1 is equal to nothing but root 2. So, now what will be the value for what is the. So, we have done some mistake here. So, here probability of x is equal to 1, it is not e to the power of not e to the power of minus lambda 1, lambda 1 to the power 1 by 1 factorial. So, that is why we did not, it is wrong. So, now we have to solve it again. So, this is nothing but now if you simplify these things. So, now e to the power of minus lambda 1 is positive, lambda 1 also positive, just we can divide by e to the power minus lambda 1 by lambda 1. So, this is lambda 1 by 2. So, which implies lambda 1 is equal to 2. Now, next relation, it is probability of y is equal to 2 is nothing but is equal to probability y is equal to 3. So, now, probability of y is equal to 2, what is the relation it is given? Probability y is equal to 2 is same as is equal to probability of y is equal to 3, which implies now it is y is Poisson distribution with probability parameter lambda 2. This probability mass function we use. This is nothing but e to the power of minus lambda 2 square by 2 factorial e to the power of minus lambda 2 whole cube by 3 factorial. So, then just we have to simplify these things. So, because these are all positive number, we can divide by e to the power minus lambda 2 square, we can divide, then this is nothing but 1 by 2, this is equal to lambda 2 by 3 factorial, this is 3 into 2. So, this implies lambda 2 is equal to 3 into 2 by 2, this is nothing but 3. So, then we found lambda 2 is equal to. Now, we know that the variance of the Poisson random variable x will be nothing but same as expected values of x, which is nothing but lambda 1, which is 2, and variance of y, this is Poisson expected values of y, same as expected values of y, this is nothing but lambda 2, this is equal to 3. Now, it is asked that find the variance of x minus 2y. So, x minus 2y variance. So, we will discuss later. Let us remember that for any two random variable. So, two random variable variance of x minus 2y, this is nothing but variance of x plus, because they are independent, variance of 2y. So, there is some other term covariance, but since it is independent, it will be, since x and y are independent random variable. So, because x and y are independent random variable, so this formula it works. Actually, we will discuss this formula later whenever we will discuss bivariate random variable. Here we are using the formula, but again we will discuss it. So, this is nothing but variance of x, that things we know that this constant will be outside this by square, because variance of a c into x is c square into variance of x, this is nothing but 4 into variance of y. So, variance of x is here nothing but lambda 1, this is 2 plus 4 into variance of the y, this is 3. So, this is nothing but 2 plus 12. So, this is nothing but 14. So, this is the answer. So, if there is any mistake, then you please check, and then you see that whether this answer is correct, or you can check whether there is any different answer. So, these are some of the example we discussed.